Okay. Well, thank you everyone and welcome aboard. We are about to start on now the planning pieces of our grade 4 curriculum for next year and doing small chunks at a time, basically just looking at the months of September and October and trying to unpack some of the pieces that we're going to need for bridging. We know that the students in grade 3 have already done the new curriculum, but we are not assuming that they are just sliding out of that grade 3 curriculum, knowing everything that they need to know to bridge into the new grade 4. So we're saying right now, let's treat it as they don't know the materials, and anything you get as a bonus after that, you can go a little bit faster. So that's kind of how we're going to leave this year. And then next year we would change sort of our year plan to reflect the fact that we would have students for 2 years that would be coming through the new curriculum. Okay, so let's get started. Let's see if we can get ourselves going here. There we go. So I'm just going to start with our land acknowledgement, and then I'm going to talk a little bit about the link that's at the bottom. So we respectfully acknowledge that we are situated on traditional lands across the province of Alberta, home to many First Nations, including the Cree, Blackfoot, Métis, Nakota Sioux, Saulteaux, Inuit, and many others whose histories, languages, and cultures continue to influence our vibrant community. And for anyone who may be wanting to indigenize some of the math that you're teaching, BC has long already had out a document which has done a lot of work with mathematics through the lens of Indigenous beliefs and practices. And that link is just at the bottom here. It's not just sort of theory, a lot of it is actual lessons. They're quite appropriate for Div 2, Div 3. So you can certainly share that with other teachers within your school board. I won't go into that one right now. I just want to keep us going here. So just a couple of sort of quick reviews of things that we did. I'm not going to go through all of our key documents, but there are just some pieces that I just want to reiterate from when we did the unpacking. So we talked a little bit about the screen that you're looking at right here and kind of the uniqueness of the grade 4s sitting in a position really a little bit different than what we have in the past with our old curriculum. You're still Div 2, that's obvious, but in the world of this new curriculum, you are very much the group that is in some cases finishing an entire organizing idea that lives in K to 3 because it ends, for example, with time, ends with you. But you're also going to have to pick up some of those big rocks in grade 3, especially the unit fraction rocks, and really make sure that the students are sound and well developed in those, because they're going to need that in 5, 6 to really unpack the pieces that they have to deal with. And so you live in a world that's not just Div 2, you live in a little bit of Div 1 still and a little bit of Div 2. So hence why I put you where I did. So when we look at kind of our organizing ideas, we see that with the white, there are definitely places in which we don't see all of our grades. So for example, our algebra doesn't start until grade 3. We see that coordinate geometry doesn't start until grade 5, 6. And it used to be just grade 6 really in the big rock. Now we're doing grade 6 and grade 5 and grade 7 and grade 6. So shifting again, those pieces that need to happen. So some work that needs to happen in the geometry section to kind of make that work in the grade 5 as well. We see measurement patterns, all of those are still following all the way through. And of course, number is in geometry. Those are kind of our big rocks. So what I want to look at today is just kind of what would we look at as far as September and October? How would we unpack it? I'm going to say the same to you that I have to pretty much anyone, but especially in Div 2, and that would be you're not teaching a unit in a little box. It's not I've got fractions for the next 3 weeks, and I'm going to be teaching that from beginning to end. The answer is it won't work. They won't have the background knowledge, and we need to take the time to spiral around and come back and revisit and revisit. Each time we revisit, we're going to amp the ante. So we're going to make it quite a bit higher expectation. When we were working with some of the pilot teachers, we kind of had a target goal that by the end of February, even March, if we were done the spiraling part and actually arrived at the grade 4 outcome to meet the outcome that as it's worded in grade 4, that gave us ample time to ensure that they fully understood it. So we have no rush, go slow to go fast later. There is no reason to worry that you're not going to finish. You're not going to reteach all of grade 3, anything like that. That's just not going to happen. We're going to look at the concepts and the verbs work again. So if you do have your numbered outcomes document sitting beside you, that's great. Or if you have it accessible, that's even better. And then we'll look at some activities that we can do with that as well. So we talked about all of these already. We've talked about the fact that we don't have the strands. The guiding question was for you, the teacher, not as an I can statement for the student. The learner outcome is what you are reporting on your report cards, and those are what the cusps have been attached to, so I know exactly how to unpack that learner outcome. And then the literacy, numeracy, and competencies are still from 2013 in vogue, every teacher, every year, every subject, right? So those are important pieces that we need to still put in there. And we did go through the new Learn Alberta site to show you where those are linked directly to your learner outcomes, but I'll be glad to go through that with anybody later if they need to. So our numbered outcomes document, remember, is exactly the same as what is sitting in New Learn Alberta. The only difference is that we attached a number to it for easy reference, for planning, for PLCs. It just makes that conversation happen a little bit easier and a little bit faster. So the first number was your grade. In this case, it's an example for grade 5. We have N for number, and we had all of those legends found in the curriculum comparison. We'll look at that in a second. The next number tells you which outcome this was as it was listed in the government order. We didn't change anything in that. And if it had a decimal behind it, that tells you whether or not it was the first row of cusps, the second row of cusps, third row of cusps, or no cusps if there was no decimal. So that's all that we did that was different in this document. Reminders for when we are planning now, that when you have the word include or including, if that shows up in any one of your descriptors, cusps, any place in your numbered outcomes, then you need to make sure that whatever comes behind those words is included in your lesson plan. You can't say, well, there's 3 listed, I like 2. We have to include them all. Not all on the same day, but we do have to include them all. Nothing can be omitted. However, it is not saying that you can't add to it. So if you have best practices, if you've done something for years and it has worked exceptionally well with your students, then you absolutely would continue to do that. You're not throwing away everything just because it's not listed there. So that's important for us to remember too, that it's not exclusive, right? We can definitely add to it. As opposed to, let's do the opposite, such as. Anything that's listed below such as are examples, exactly that. There's such as, I don't have to use them if I don't want to, but I can use one of them, all of them, none of them, because I have better ones that I want to use. As long as I meet the outcome, you're pretty easy to go with that. And then the last one, we don't see as many. I'm not sure who S. Jacob is, but can you mute yourself? Because I'm not able to mute you for some reason.
Shobha doesn't have a mic or anything here. She doesn't, I'm in the same room as Shobha.
Okay.
So she doesn't actually have a mic or anything. I don't know if it's, yeah.
All right, then I'm not
Now
sure
you're in
where
the same
that's
room.
coming from, but
It's from
we'll
Betty,
see.
or I don't know. Shobha's no camera, no mic.
Okay, well,
He's
that's not
listening
good.
with me.
All right, so words that are in brackets become less and less as we go 4, 5, 6. But if I do see them in brackets, that means that that word is the mathematical term. But for maybe obvious reasons, it might be too difficult for a student to handle. And so there's a suggested word that's more of a lay language that sits in front of it. And if that is easier for your students to understand, then feel free. In most cases, right from grade 2 up, the teachers have said, I probably would still show them and talk to them about the word and still teach them the word. I might not use it every day, and that's fine. but just so that you're aware that you might have some lay language there. And also when we talk about the verbs that live in this particular curriculum, one of the things that we have the benefit of is when you're working from K to 6, both in math and in science, you see that often there were different authors, but you also see that often a verb is being used in one grade and then another, when in fact their intent is actually to mean exactly the same thing. So the context in which a verb is put in, we need to pay attention to, because it could mean another word and logistically mean that word, that's actually the one that you might want to use. So just because it says interpret doesn't mean I couldn't make it an identify or a compose or a recognize, for example, in this one. Whereas if I use interpret over here, it could be any one of these that could come up into play. And we're seeing more and more and more of that as we start working our way through the curriculum, where in fact there's really a couple of verbs that are used way more than others. And the intent was actually that was the verb that probably all the authors wanted to use, but they used a different word. So although we have verbs that are inlaid directly into our curriculum, both Ted and I in math, in science, I'm saying it in math as well, you need to put that in the context of what it was. And if one of these is a better verb, then go ahead and use it, because I think that would be more concise with what you're going to do with the students. We have the curriculum comparison document, which basically showed you on the left-hand column, what was it that we used to teach? What were the learner outcomes that we had? What were the numbers of those outcomes? And how did those in the left-hand column now fit with the new ones in our new curriculum? And it was at the top of the curriculum comparison document that you had your legend for the letters, for N for number, T for time, P for patterns, and the colors that went along with them. So that's a document that we're suggesting have a numbered outcomes document and a curriculum comparison document on your desk pretty much for the year that you can use as your working copy to make notes on and just say, yeah, I'm able to go faster in this, had to go slow, didn't know this. Okay, those are the kinds of pieces that you want to have. Okay, yep, I will get you the link for those, you betcha. And so when we have the year at a glance, that was your final of the 3 documents. And those 3 documents together basically kind of what we called our keys. This year at a glance was the document that says, here's what's happening sort of month by month. And we're going to unpack that one today. That one I'll have up on the screen. So that's the one we're going to spend most of our time on for now. It looks like this, and the color coding that was in that kind of linked to that legend that was at the top of the curriculum comparison. Now, when I look at this, I see a lot of pink, and the pink was number, and that kind of sort of makes sense because number is a big component of what we do. Again, the the year at a glance is a suggested. If you don't want to follow that and you want to go in a different order, that's entirely your decision. We will, in the PDs, unfold these using the year at a glance. That doesn't mean you have to follow that. You could use the resources that we're suggesting. You could use the year at a glance then to look at what are we suggesting for bridging, depending on where you want to start. And that would be another way that you could use it as well. So let's just run through this again. It comes in 3. We're only going to look at September and October, but just so that everybody's clear on it. At the top, we have our number. This is our organizing, our organizing idea. And then you have the outcome, the learner outcomes that we want to stress in this month. And they don't necessarily go in numerical order. There was never any intent that you would pick up the outcomes that the government gave us, the numbered outcomes document, and teach it in the order that it was there. You would mix and match depending on where you're starting, what your focus was, and in this case, what their background knowledge is, where can I fit pieces together? That will be the other component that we want to have. So in here, I have the learner outcome, and the bullets are the understandings, not your knowledge and skills. So these bullets are your understandings, and the understanding is the key. It is the most important part of our curriculum. It is what's saying we've got this. So if you've done the skills and procedures and the knowledge components of it and blended those to something beyond just a surface level teaching, we're moving towards what that understanding is. So it's the understanding that we really want to pay attention to and make sure that we're getting that. So as we start going through this, when you see things in yellow, the things in yellow are what we're suggesting might be starting points to get going. In other words, if we were doing this live, one of the very first things that we ask the participants to do is just make a note of how do you normally start in September? I don't care about new curriculum or not. How do you normally start teaching your class in September? And usually it's I got to get to know the kids. I need to know what their background knowledge is, all those lists of things. And you had a usual routine that you would follow, and you're not going to change that routine. That's going to be the same regardless of the fact that they have a new curriculum. I need to pay more attention and I listen intently to what they know and don't know, but I still need to know where is my starting point. And then I need to just be very much more aware of what is it that I would have normally just launched into and assumed that they know where they might not. And so we're going to assume they don't. We'll start small and then work our way to progressively higher and a little bit more difficult. So that's basically how this was laid out. Anything that was in green is what the pilot teachers asked us to just put it there because it happens all year. It's going to happen all year. We're going to do math facts all year. We're going to do time all year. So wherever the teachable moment comes in and appropriately, we're just going to throw it in and we're going to keep doing it. So it doesn't necessarily have to be a strategic piece of just every day's lesson plan. So you'll see that in September, October, we also are still continuing on. We've got another one here, 4N 5.2, students apply equivalence to the interpretation of fractions. Are we starting with fractions in September? Absolutely not. Are we going to do all of that outcome in September? Absolutely not. We're starting small. So we're listing it, but you'll see that it even shows up in October. So we're going to keep doing work with it and we're going to revisit it as the time goes on. We also see that in October, we're also going to be doing some things on measurement. Are we going to do it all in measurement? No, we're going to do bits and pieces of it. We also have algebra that is starting and small components of it. Again, we're going to integrate pieces so that when we're doing the activities with the students, you're going to be doing outcomes from all these different organizing ideas, but you're still just checking to see what is their foundational knowledge and where are we coming from. All right, so in the files that I'll share with you later, we've started a bit of a sort of a mirror that we do with science, and we always create a concept map. Is it the only concept map? Absolutely not. It is one version of a concept map. It is one way to look at how does all this stuff that you just showed me fit together? Like, how is it I'm supposed to take algebra and fit it with measurement and fit it with all these ones that came from number? And the answer is we're going to be very deliberate in what it is we unpack. We are going to use money. And I'm going to say that right up front. We're going to use money, not just for financial literacy, but because we want to leverage that for learning how the students know their different operations. Do they know how to add? Do they know what decimal numbers are? And the answer is, I don't care about decimals right now. I just want to know if they can add. Can they even do to 100? Can they do to 1,000? Right? Where are they at? What is their mastery level? So we're going to leverage money for as much of those pieces as we can. So for example, I might be doing number and I'm going to be looking at money. I'm going to be unpacking the money. I'm going to be talking about place value of money with money in front of me. So if I have the number $124, and I say, what number is in the tens position? The students can see it, 1, 2, 4, they know that. They can also see it. There's two $10 bills in front of me. But if I were to change that to a place value question and say how many tens in the question, and they come back and say 2, then are they really understanding what that means? If I were to say to them, let me just ask the question again. If you can only pay me out in $10 bills, how many tens in the question? Oh, okay. This is where we lose kids, where they just think that place value sometimes is just about columns and numbers in a column. We have number lines. We're going to take the number lines and put money on the number line. We're going to talk about unit fractions that they should have really got really well done in grade 3, but maybe they didn't. So we're going to start again, just find out where they're at. So this is how we kind of link these together. I know it's hard to see on the screen right now, but you do have a copy of that I'll give you later. Okay, so let's be deliberate. Let's just look at September, October. So in September and October, we have all of these different pieces here. And what I'm going to show you on the next slide is 4N1. Okay, this is where this starts in 4N1. We're not doing everything. We're just going to start surface level. But before I do that, what I want to do is make sure that all of you are okay in finding the concepts, whether you teach in High Prairie or whether you're coming to us from Lethbridge. We have to be able to find the big rocks in this because that's what you're assessing. And if we're all going to be assessing the same thing, then we all should be finding the same big concepts. If you have your document in front of you, your numbered outcomes document, great. If you don't, what I'd like you to do is just have a look at what's on the screen. Just maybe we don't have time to do the whole thing, but maybe just do one paragraph or two paragraphs in each one and just jot it down on a piece of paper. You don't have to put it in the chat box. You're not going to share it. A concept, remember, is a noun. A concept is a general term. It sits out there, and until I know how I'm going to unpack that specifically for my grade, it's a very big, broad term. It wouldn't matter whether we teach in Alberta or whether we teach in Alabama or whether we teach in Japan. That word would have meaning anywhere in the world, regardless of what language they speak. So it's not just about North America. It's universal. So if I were to go to just even look at students apply place value to decimal numbers. So if I talk about it, students are a concept. Not that that's overly significant at this point. Place value. They can be one, maybe two words, never a sentence, never a phrase. Decimal numbers, the most correct thing to highlight would be numbers. But because we're going to talk about specific numbers right now, if you write down decimal numbers, absolutely fine. Okay, I'm just going to give you just a second to look at maybe just the first two pieces on there, and then we'll just move on from there. I will give you the concepts as well. Just want to make sure everybody feels comfortable finding them. And the one thing that should happen is that you should be writing down the same word over and over and over again. Like you just say, hey, I don't know, I keep writing down or circling or whatever, and that's exactly correct. So when I look at all of these, I see things like number, place value, I see value, I see number, I see place value, I see position, I see decimal separator, point, comma. It all leads to sort of a theme of numbers, decimals, place value, numbers, decimals, place value. So if I kind of get lost and I go off on a tangent and it's really not hitting those highlighted words, I'm probably not working in the umbrella of what this cusp is asking us to really focus on. And that's what highlighting this does. It kind of gives you consolidated vision of what are the big rocks that live in those three columns. And I should see them over and over and over again. So that we don't kind of just teach a one-off thing and spend maybe 5 minutes on it and then ask 5 questions on an assessment. And then kids turn around and say, well, we only spent like a little bit of time and there were so many questions on there. Was it really the big rock that lived in here? Anybody who lives anywhere in Alberta would be highlighting the same words, so therefore assessing the same things. And that's the importance of these concepts. They really consolidate what those 3 columns are asking us to focus on. And when I look at the understandings, in the first understanding, decimal numbers are numbers between natural numbers. So I need to know natural numbers and decimal numbers. And can I work with those? And do the students understand the differences between them? How do I find them on a number line? How would I identify them? And what better way to do that than have money in my head first? Because if I don't get decimals, $1.26 and $1.27 makes way more sense to me if I say which is larger, 1.26 or 1.27. If I know money first, then I know that in $1.27 I have more money. So that's bigger. For some students, and I know that seems like it should be obvious, but you already know that not all students have that understanding. They're not able to really visualize what decimal 2.6 and decimal 2.7 look like. So there's the importance of money. So when we unpack these, we actually go through, and I'll put little notes like this on the side to give you some starting points as to how do we just get into this in September. So working within 100, do they have mastery of 100? And if they've got 100, then try 200. And if they've got 200, try 500. And if they're good with 500, then let's go to 1,000. But there's no rush to get to 100,000. And there's no rush to think you're going to go beyond that. Certainly not in September and October. Mastery of 100 in every possible avenue that you can come up with. Make sure they've got it. Because if you've got that, then we have an easy step forward. If I always have to keep playing catch up, I'm going to never get done, right? So I need to make sure that they have that. Learn money and their values. That should be the kindergarten one. But let's not assume that every grade 4 student knows money. Let's not assume that every grade 3 student was exposed to money and working with money. They might know the name of the coin, but they might not really know a lot about it. So start from scratch, and anything they know, celebrate it and move forward. But we really want to just talk about whole number dollar amounts. You're going to get to decimals. There's no rush to do that in September. Just do whole number dollar amounts. Can they show you $32? Can they show you $48? Can they add those two together using a base 10 system? If they can, great. If they can't, let's work on that. That's a simple 2-digit addition that grade 2 students should be able to do. Maybe they didn't get that, right? So let's just move forward using whole dollar amounts. Can they then make change? Do they know how many cents go in a dollar? If I gave you $5 and I bought something or I paid you $5 and I bought something for $3.28, can they count up to give us the old-fashioned way of making change? And that's absolutely important for them later down the road when we do decimal numbers. Just doing that, put little sticky notes all around your room with a variety of different prices, some in cents. Start with cents, then go to dollars and cents, and let them go buy things and tell them how much they're going to give you back. That's kind of a critical understanding for decimals, but all we want to do is talk dollars and cents. Don't talk to me about tenths. Don't talk to me about hundredths. I know it's in the curriculum, but I don't need it. Just talk dollars and cents. Because if they get the money down pat, they will understand the tenths and hundredths later. It'll come out. They'll tell you instead of you telling them. And that's our goal. Get the kids to tell us what they know. So making change to $1, $5, $10, change for $100. Let them buy 2 items and add them together. And if they're only doing whole numbers, that's fine. And if they're doing whole numbers, dollars and cents, and some students don't know how to add decimals, absolutely perfect, because we haven't spent any time doing that. So what we found students doing is they would take all the whole dollar amounts and add them together physically. They just add them together in front of them. They would take all the change and add it together, knowing that when they got to 100, they could trade it for a loonie. Whatever was left over that wasn't 100 was their cents. And that's okay too. Just sliding all the coins and cents together and doing that kind of an addition initially is great. That's perfect. Compare money amounts. Who spends more if I buy something for $10.54 versus $10.45? Who's spending more? Who's spending less? Simple. I think everybody would say, oh, well, that's a no-brainer. But if that's a no-brainer, if you understand money, if you've never actually done that before, then that's not so easy, right? So just making those kinds of fun activities for them. Describing 2-digit and 3-digit dollar amounts. Can you call out? Show me $54, show me $46. And we are going to work on what's called a base 10 system, and I'll show you that in just a second. There's 2 sort of money bags that you can have, one that has a variety of everything in it. And if they don't know any money at all, then get the variety bag out where they have pennies and dimes and nickels and quarters, like everything. But if they know their money, then we're going to deal with a base 10 system only. So, because we're not going to bring out our base 10 blocks for a little while. We're just going to use the money to replace the base 10 blocks. And I'll talk a lot about the money base 10 in just a second. Practice reading and writing 3-digit numbers so I can call them out. Can they show them to me? What if I put the words up? $254.27. Can they see the words and put the number down in front of you? It would be the same as writing the numbers. We're just doing it with money first, right? So just those types of things give you a very good indication of what they understand about values, about number, about whether or not they can write those numbers, whether they interpret the numbers. So doing all kinds of just fun activities that keep going through that over and over and over again. And then I can ask them, can you show me $54? How many tens do you have in $54? How many loonies would you have in $54? Right? Different question. So again, just making them think about different forms, value, place value of the dollars. Regrouping money using the mats, and I'll show you those again. So can they regroup? They know that 5 pennies is a nickel. Do they know that 2 nickels is a dime? Do they know if they had 5 nickels, they could trade it for a quarter? Just doing those kinds of things. And one of the best ways to do that is just have a whole bunch of coins in a bucket. I reach in with my hand, I put it on my desk, I sort them out, and do I have any that I can trade? Everybody gets a random amount, nobody's is the same. Have my grade partner or my shoulder partner check what I'm doing. Roll a dice, what's the largest number that they can have? So have 3 different colored dice. Throw them. Okay, let's just stick to 100 first. So 3 different colors. What's the largest number that they can create? What's the smallest number that they can create? Take dominoes, turn dominoes over, 2 of them end to end. And if they're just 6s, what's the smallest number that they could write? What's the largest number that they could write? And then if you want to bump it up one, let's do 9s. So when you have dominoes with a maximum number of 9 on them, I could mix and match a 9 and a 6. What's the largest number? What's the smallest number? And then let's bump it up even one more. You can get dominoes, you can get them at Walmart, have 12s on them. What if I put 2 of those end to end? And what happens if one of them is a 12 and one of them is an 11? How are they going to handle that? Right? So again, it's just a fun way for them to let you know what they know about numbers. Multiplying the dice. So in grade 3, they should have mastered 10 by 10. There's something else I want to check. Do they know their math facts? And we're going to play a game or show you a game where they can do that. So even if I didn't learn them, I can still play and I'm going to learn them as I go. But you need to check who knows 10 by 10, who doesn't know 10 by 10. And remember, at the end of grade 4, they're to master 12 by 12. And then in theory, the grade 5, 6 teachers will never have to worry about teaching math facts because they've aced it coming out of grade 4, right? We know that's not going to be the case, but there isn't a provision, there isn't an outcome that says revisit. So we're going to have to do that. You could use those subitizing cards that we've shown many times. What if I showed the 2 of them, rolled them over, multiply them, add them, just quick mental math. Where are your kids at? And once you get a sense of where they're at, especially with the multiplication and the money, you definitely want to pair them of like ability. You don't want to put somebody who's got high ability and money with somebody who doesn't, because they're going to take over every time. So you want to find out where your students at and partner them based on ability. So we have these subitizing cards that we've used. Remember, you've got dies that you can vary. So once I know a little bit about you, and once I know what you can do for addition, multiplication, I can change the dies. I can partner you with different level dies. Maybe you've got some kids that are already ready for 10 by 10. They know them all, right? So then change the die. It doesn't have to be a 6 by 6 die. It could be one that's larger and one that's a 6. Could be dominoes that go to 6, dominoes that go to 9, or dominoes that go to 12, right? Pick and choose depending on what I want you to do. And this will be a great one for them to use in grade 4 as they work their way to Math Facts 12 by 12. So they're called Mexican dominoes, and you can purchase them at Walmart. They come in a little suitcase, a silver suitcase. And that's all I use them for. I don't play the game, but I mean, obviously it's a game as well, but nonetheless, you've got options there. These are the mats that we were talking about. So for those who've been working alongside already over other grades, you've seen these before. These have been posted, and I will show you where they're posted, but they've been created for every level. So this is a beginner one. I'm just checking to see, do they know that 5 pennies would give me a nickel? Do they know 2 nickels would give me a dime? How do I make a quarter? What do I need, right? So those mats have been created and it'll go all the way up to $1,000 bill. So those are the pieces that we want to make sure that they're really good at, really fast at. So here's my loonie to a $5 bill, 2 5s to a 10, 5 of those to a 50. This is not base 10. This is just knowing money. So if you're checking to see whether I know the money, great. And if I know it, then I don't have to deal with all of the bills all the time. If I want to talk about base 10, I want to think like a base 10 block, but I want it in terms of money. And if you can hang in there with money almost right till Christmas, bring out the base 10 blocks after, we will be sailing with those. Not a problem. So 10 of my loonies, there's my 1 unit in the base 10, gives me a $10 bill. 10 $10 bills, 10 rods give me 100 or a flat. 10 flats give me 1,000. And on the template, we put a $1,000 bill. Just remind students that $1,000 bills are like pennies. They don't exist anymore. So it looks like this, but we don't actually have it. So here is your base 10 mat. So when I talk about money in grades 4, 5, and 6, a lot of times teachers will say, so what would you recommend we do? Would you say that we should just use base 10? And my answer is, if you can. If the kids know the money already, just make your own. If you have to order money and you don't have any for grades 4, 5, and 6, then I would be using some of the base 10 only for grades 4, 5, and 6, because they're gonna benefit from that a lot more, given what you have to teach them for decimals. I know there's a decimal here. They don't need to know that right off the bat. Okay, that'll come once they're working with dollars and cents. So this is my base 10, 10 of these to then to here, 10 of these to here, 10 of these, and just shifting up to 10, right? That's all we're doing. So here is kind of a suggested, and you'll have this slide deck later so that you'll be able to bring this up. But if you wanted to make a variety of different coins in a bag, then you might want to do what's on the left-hand side. If you have elementary in your school and they already have money made in bags, then just borrow it. You don't necessarily need to make another set for 4, 5, and 6. What would be more important would be this bag here, is just creating the base 10 system. Now, having said that, one of the things that we always run into is we ran out enough loonies, we don't have enough $10 bills, blah, blah, blah. So I have approached Spectrum to create for us mega bags. So I said, I don't need all the stuff. Like I don't need the nickels and I don't need all the quarters. What I really need is a base 10 system. So can you make me a bag with 1,000 pennies, a bag with 1,000 dimes in it, a bag with 1,000 loonies in it? So they have created those and I'm just waiting for the pricing to find out how much they're going to be. So that way we can just take a handful and put it in a bag. We don't have to worry about them running out. So there's some options that are coming up there for sure. But I start with cents first. If your students don't know the money, start with cents. Start with cents, get them to work with cents, show you cents, and you're borrowing those bags from elementary or creating, whichever. Can they show you 103 cents? Can they show you 137 cents? Can they show you 174 cents? And once they got it, check it, and then say, don't touch it. Now you have to show me it again with the money that's left over. So making them regroup, making them look at the different values that will combine that will give me those amounts. That's absolutely critical mastery, getting to 100 and over 100. So those are important pieces for them to do. Looking at 100 pennies is the same as $1, but sometimes students need to see what does 100 pennies actually look like. So I see some students will say to you, I see 2 rows of 5 or 2 groups of 5. Some students will say, I don't, I see a group of 10. So they'll go 5, 10, some will go 10, 20, 30, 40, whichever, but you also want to hear that. Let them say that too, because that's that skip counting that was done in grade 1 and grade 2 now, right? There's no more skip counting because it's all done at the end of grade 2. So let's make sure that they know how to do that. Can they skip count by 5s? Can they skip count by 10s, right? How do I see this? I might see a group again. Ask them to explain what they see. How do they know there's 100 there? What was their reasoning behind it? Because cents are not the way we go shopping, it's an important question to ask your students. What is it when you go shopping that you see? And when we asked students, do we see 196 with a cent sign behind it on sale signs when they go to the store? Students said no, but what they didn't say is you see dollars and cents. What they said is you see an S sign with a line that goes through it. And that tells you right off the bat that, wow, maybe they don't know what they're looking at. They know it doesn't look the same, but they don't really know what it is. Not all students could tell us that was the dollar sign. Not all students knew what a cent sign was. So again, don't enter the grade 4 world assuming that they know this. And there's no need to rush it. We can add, we can subtract, we can multiply, do all those kinds of things with money. We can skip count with the bills. So there's lots of things that we can do. But to get around this whole notion of how do I change this from dollars and cents? And for those of you who've used base 10 blocks for years and taught decimals, you also know that there's some confusion that comes in when you say to a student, here is my 1 unit, here's my rod, which is 10, here's my flat, which is 100, here's my cube, which is 1,000. And now we've been doing this, and you're going to say, okay, we're going to deal with decimals now, but we're going to change the rules. So the flat is now a 1. And the kids who never understood why they even had to learn why they were regrouping these plastic things just fell off the rails, because they're saying, I thought that was 100. Well, it was, but now we're going to call this a 1, and we're going to call the rod a tenths. So again, I'm learning that because you're telling it to me. I'm not learning it because I figured it out for myself. So this is why we say leave the sort of base 10 blocks alone and just deal with money. So one of the places they do this in other countries is they take the flat and turn it over. And if you turn over the flat, there's 100 holes. 100 holes is like 100 pennies. 100 pennies gives me a loonie. So if I had 196 pennies, I would have filled this entire surface once, traded that for a loonie, and then I would have 96 or 4 holes left over. And that's actually a brilliant way of doing it. So again, showing our students who need to see that, putting that down in front of them is helpful. Most of your students at the end of 2 days will say, I don't need that anymore. I got it. But that's okay. Let them to come up with that. So here's 103 cents, right? $1.03. So showing me 126 or $1.26 gives me an option to really replace the kind of work that I was doing before in base 10s with just changing this to a loonie. So when you bring them back out later after Christmas and they see this, they will say to you, that's $1. So the kids who are stuck in the abstract world of why I'm dealing with the plastic will just change it to money. That's real. This is real. This is abstract. All correct, but just very abstract for some kids. Here is what it would look like if I was talking about $12.51. What I'm really doing is I'm creating with dollars the same thing that I want them to get to eventually, not in September, not in October. Just do dollars and cents. Talk about money. So this is what you're doing is you're trading sort of that notion of having a single little unit for a penny. You're trading a bar or a rod for a dime. You're trading this to be a loonie. So you're doing exactly the same thing in base 10 money as you did with the blocks, only I don't have to change the rules. I just keep flowing it through. And that's what makes it a little bit more manageable for the kids. They get that piece. Okay, let's look at your second one. Students add and subtract within 10,000, including decimal numbers to hundreds. Are we doing that in September, October? Nope. We're going to just make sure that they understand, first of all, that they can come up with numbers. We're still working on numbers to 100. If they got the 100, go 200, 500, blah, blah, blah. You're dealing with money. So this tells me again, can they add and subtract a whole number amount? Can I ask them to show me $156 and add to that $37? Can they regroup? Do they know that more than 10 loonies, I get to trade it off for a $10 bill? That's the kind of thing that we want them to do quickly. And once they get that, you can try and introduce dollars and cents, just talking dollars and cents, not decimal numbers. So I'm just working on basic pieces. So it says, do initially whole numbers, work your way up to 1,000. Can they show you $454? Can they show you $629? Can they add those two numbers together? What would they get, right? This is already coming from grades that they should be able to do that. So they're comparing numbers. Can they compare who has more money? Can they do numbers between 0 and 100 on a number line in dollars and cents? Dollars first, then cents, dollars and cents. So when we say to a grade 6 student, for example, put these numbers, fractions, decimals, whole numbers, integers, all on a number line, and they tank because they have no idea conceptually where these decimal numbers belong. Had we shown them money first, that would be a non-issue. 6 cents, 0.6 versus 1.9. Okay, they get it. They get it 6 cents versus 19 cents. So in terms of putting it in a real world context for students, it makes it better. So we're starting really small. We're starting with paper folding. And if you're not sure how to create a unit fraction with a paper fold, send me an email, and what I will do is just record it for you. Because in the real world of live, we do this aside with the teachers. We create everything we can in paper folding, so that if a student knows how to find 0 to 100, can you find me 26 from 0 to 100 just on a piece of paper? Not with a ruler, just a piece of paper or a piece of string. How would they do that? What tools do they have in their back pocket to understand what that means? If I said that the paper went from 0 to 500, could you find me 126 on that piece of paper? Where would it belong? So those are the kinds of things that we want them to be able, and they should be able to do a good portion of that already, because they would have done that investigating numbers to 100,000 in grade 3. Do your kids know that coming into grade 4, right? No rush. We can do that with them. We can start right from the beginning and work our way through. So paper folding is one way to not only find numbers on a number line, but it also then brings into play the unit fractions that they should have understood in grade 3 as well. Absolutely critical for you to pick up in grade 4. In October, we're looking at students explain properties of prime and composite numbers. Well, I'm not going to do primes and I'm not going to do composites. I am going to find out whether or not you know math facts first, because I can't really talk about that unless I know that you have some math fact that you can work from. And then I can talk about what does it take to get the number 6, 2 and a 3. So I can talk about whether that's a prime or composite number later. But if I don't know my math facts, you're going to be banging your head against the wall trying to unpackage that for me, because I don't even know what 2 numbers multiply to 6. So I need to practice that first. Lots of games, lots of ways that they can do that. So working on your facts 10 by 10, then we can start doing that. Doing factor trees. Those are fun races for the kids, but excellent math. Give me a number. Can you break that number down into 2? Can you break it down any more, right? Eventually, what are you getting? You're getting the primes. They don't know that. They don't need to know that right off the bat. Just can they do it? We can bring the terminology of primes and composites in after. Just get them to make sure that they know what they're doing. Can they do money arrays to show you multiplication facts to 100? Can they do dice and grids? And we'll do a grid one. That's one that we'll play with just a second. So again, let's look at 4. Students multiply and divide natural numbers to 10,000. Don't worry about 10,000. That's coming later. If they don't know multiplying to 100, how are you going to get them to 10,000, right? So let's work on this. So this is where I say that September, October is very much a building month. It's really a honing month. It's a let me get my feet under me again and make sure that I've got really good foundational skills. You can go faster later, but just find out where they're at, pod them so that we get some work forward, keep revisiting all these different pieces. So again, you're doing the rolling the die, find the larger number, you're still multiplying, you're using subitizing, arranging. So you're doing all these outcomes, doing the same kinds of activities over and over, just through a different lens. That's all you're doing. And the kids don't know that they're hitting outcomes at the same time. Okay, when we look at 5.1, students apply equivalence to the interpretation of fractions. So equivalence, I'm not going to do fractions. Let's just do whole numbers first. Show me $54. I don't care how they show it to me. Now show me $54 another way. Show me another way to add to $50. So equivalence meaning that I can come up with a dollar amount in umpteen different ways. So I just get the notion that they are still equivalent because they all add up to $54. How I got there could be very different than the partner that's sitting beside me. Just start small. Again, this gives students the confidence. They get to show you what they know. They work from there. So show that they know how many dimes and pennies are in a dollar so that I can make that equivalent, right? Put in the number line, the money labeling in cents. Can they put a number on a number line? Can they put a number from 0 to 50 on a number line that's in dollars and cents? Can they do it to 100? Same thing we just did. So I'm just bringing all of this stuff back. And then again, when we start looking at 5.2, students apply equivalence to the interpretation of fractions. I'm not worried about fractions. Fractions are a part of something. We're going to use that by putting our money onto a number line. Do they know where dimes go onto a number line when I skip count by tens? Do they know where nickels go onto a number line when I skip count by fives? That's important. And why is it important? A, I know that how many I need to get to 100. B, I know how to put them on a number line. And C, there are your unit fractions. We need to count by unit fractions. So what does that look like? So here's my dimes, and some of you that worked with us before have seen this slide before. This is where I revisit. Do they know that I'm going to put 10 dimes on a number line and the increments of 10 cents? So instead of having just a number line, put cents behind it. We just had the kids write cents down. Put a dime above each one. What does that mean? Well, it means that I have 10 dimes to make 100. This is my first dime out of 10. This is my second dime out of 10, not numerator is 1, denominator is 10. We don't need that language for fractions right off the bat. Absolutely not. Just do it as counting. Do they know to count by a unit fraction just like you taught them in grade 1 to count by 1, 2, 3, 4, 5 on a number line? So here's my first out of 10 hops. Here's my second 1 out of 10 hops. Here's my third 1 out of 10 hops. What's my unit fraction? 1 out of 10. I need 1 out of 10, 10 times to get to the end. What would it look like if it was nickels, right? We want them to be able to transfer that knowledge to nickels. So here's how some students wrote their 1 out of 10 hops. Some of them automatically said it's my second out of 10, my third out of 10. Some didn't. They wrote it just like they said it. It's my second bracket 1/10 hop. So just taking a number line like this, I put a note on the bottom here. There's a link where you could buy this particular number line if you want. And all I did was photocopy. I actually put 4 of them on a big page, a ledger page, so that students could put dimes and nickels and pennies and quarters all on the same page. So here's what some students, this is a student work where we took the pictures of what they did for nickels. So we said, what kind of hop are you doing now? Well, I needed 20 nickels when I got them all on the number line to get to 100. So this is my first out of 20 hops, my second out of 20 hops, my third out of 20 hops. All they're doing is counting by a unit fraction of 1/20th. They don't need to know denominators and numerator language. That'll all come later. If I've got it, then I should be able to say everything down the left is 0, everything down the right is 1. How many hops would I do? And I would do the first one with them. How many hops do we have? I have 1, 2. So this is my first 1 out of 2. This would be my second 1 out of 2. Great. Now you finish the rest. And the link that you have down here is just a link to the blank. So if you wanted to print one off. But that's the unit hopping that they should be able to do from grade 3. Check it, make sure that they can do that, because that will help us later when we get into the fraction conversation and when we talk about equivalent fractions and things like that. So here's a sample of what students did. This is a screenshot from one of the kids. So they did all of their work. This student actually writes it as they said it. This is my second 1/4 hop. This is my third 1/4 hop, my fourth 1/4 hop. So that's how they wrote it, which is actually kind of brilliant for us because in grade 5, when we do multiplication, multiplying a whole number by a proper fraction, what do? I tell them that the numerator gets multiplied by the whole number in front, and you get 3/4. That's actually how it happens. So this is a nice way to get there. And then the added piece that I ask them to do is, which one of these lines has money to it? Show me the equivalent for money. Which one of these has a money amount that you could find? 50 was easy. Quarter was easy. The $20 bill, they had to find that 1/5 piece. That wasn't so easy for them to find. What if I move the 1? How does that change things? So I still have to hop. First hop out of 2, second hop out of 2. Now I've got 1, 2. So this is my first hop out of 2, my second hop out of 2, but now I have another one. I have a third hop of 1/2 or 3 1/2s. So they're getting into an improper fraction. You're not talking about improper fractions in grade 4. That doesn't mean that they can't hop, but we're not dealing with that. But that's the grade 5s. This is the groundwork for grade 5. And they absolutely need to understand how to get there to do that. So I can have this conversation. I can say to them, wow, how come this was my first out of 2 hops, 2 out of 2, but over here I see it out of here and here. Like, why did that happen? So they need to understand that the whole can be different, right? How far I have to go for the whole can be different, but the amount that I'm hopping can be represented by the same. So that's important, and that comes from grade 3. That's grade 3 understanding, but not all kids will have gotten that right off the bat. So again, it lets me get into that conversation. I can see that I can go, this is an easiest one for me to have that conversation with because you've been teaching me money all along. So I can say, when I have 4 quarters, how much money do I have? I have $1. But when I have 5 quarters, how much money do I have? I have $1.25. Great. Now I could write $1.25. Or I have 1 and 1/4. I have $1 and 1/4. Now I have a meaning for 5/4. Even though I don't need to do that, I can do that with money, put it in those terms. Okay, we also have measurement. So how does measurement get into all of this? So measurement talks about, in this case, students interpret and express area. So yes, we want them to know area. No, we are not going to go into it and say length times width equals the area of a rectangle. That is all true, but we want them to come to us with that later, not us tell them tell us. But how could I leverage this outcome to get started and leverage the fact that I need to make sure that they know their multiplication facts? So one of the games that we do a lot of with students is we play this game on a grid paper. So you could use a normal, just a sheet of small 1/2 centimeter grid squares, or what we do is we use an 11 by 17 page and make them a little bit larger and make the whole page on 11 by 17 grids. In either way, what I'm going to do is I'm just going to do multiplication, straight multiplication facts. But what if I'm a kid who came to you in from grade 3 and I don't know any of my math facts? So we're going to practice math facts, but I don't know any. Well, this is a great way for me to learn them, because now I'm going to, let's say Julia and I are partners. So I might be red and Julia's going to have green or whatever color marker she has. Right now I'm just showing mine, but you would do them on the same page. So I roll 2 dice. I don't know what 1 times 3 is, but I can diagram out 1 by 3 and I make my rectangle. So if I'm a student in your class who doesn't know what 1 times 3 is, I can count it. And we would tell them to put in here 1 times 3. They would write it down. 1 times 3 equals 3. Eventually, they're going to roll these numbers over and over. They're going to see it. And we hear from kids saying, I just had that one. I know what that is. It's this, right? So they just, through practice of a game, start to refresh their memory. So the idea here is that we would alternate. And we would put our rectangle, whatever I roll, I would put it in there. If I'm red, I shade it in. Julie would do hers, and let's say she gets 1 here and she puts it over here, and that's her big rectangle. She writes in whatever she got, 4 times 5 and equals 20. Eventually, we're going to fill up our sheet to a point that we can't necessarily just throw our rectangle down anymore. So what happens is, if 3 times in a row I roll and I can't put anything down, it ends the game. But that doesn't mean I win. What it means is that now they're going to mentally add what were the total area that they had. What if a kid can't do the mental math? They can count the squares, right? Nobody gets left behind here. So they can count the squares, find the area. Whoever covered more of the paper is the actual winner of the game. This was a great one. And the teacher, when we do this live, we actually do the activity. This is a great one that teacher said, oh my God, if my kids they absolutely don't know their math facts, but this would be a great way for them to learn it. Now, here's my other point to you though. Do your students know that when they're learning their math fact, that every math fact is an area? Do they know? And that's the reason we're doing this, is later we're going to come back to that and say, do you remember when you went 3 by 5 and you wrote 3 times 5 is 15? What did that mean? Well, it meant that you had 15 squares that you covered. Right. And did you know that every time you did a multiplication, you actually got a rectangle? So it starts to make them realize that any math fact of multiplication is an area. And kids in high school don't even understand that. They don't understand that anything that's multiplied is actually an area. It covers a surface. So later we can come back and say, when you had 3 by 5, would you still have covered the same amount if it had been 5 by 3? And if they're not sure, they can check. Now we're going to introduce that area conversation. But there's no rush. And what I want them to do is tell me, how do you know how many squares will be in there? How do you know how many will sit inside your rectangle? What tells you that? Let them come back to us with length times width. So again, this is just a game to get started first on how to learn my math facts. Later, I'm going to leverage it for the area conversation. Again, you're linking measurement into your math facts, just getting them to know it. So we've talked about money. In the slide deck, I'm also going to share with you, I had gone through and worked every outcome that exists from kindergarten to grade 6. And so you're going to get that link in here. But what you're getting is anything that's highlighted means that's an outcome that could have been done with money. So the question I get asked often is, well, are you saying we shouldn't use base 10 blocks? I'm saying, no, absolutely, we're going to use them. Just don't use them first. Don't use them right up front. Bring out the money, get them to learn money, get them to really understand dollars and cents for all the things that we need later, the decimals, the tenths, the hundreds, the addition of decimals. When a student says, I don't get why I'm supposed to line up this decimal. Like, why does it matter where I put it? But if I understand dollars and cents, you already know that there's 2 digits behind the decimal. Those are cents. Cents go with cents, dollars go with dollars. That makes sense to kids. But just abstractly to tell me to line up the decimal and putting me in grid paper to make sure that I understand that I line up the decimal doesn't get me to understand why I'm doing that, right? So give me a real world context. Money's real. I walk around with money in my pocket. I do not walk around base 10 blocks in my pocket, but I am going to use the base 10 blocks. So in here, when you click this on, you'll get all of the outcomes. Anything that's highlighted, you'll see it is numerous. About 60 to 70% of your outcomes could be done with money. There's no reason to rush into anything else. So be intentional. If your kids haven't done a lot with money, they might be interested to learn something about Canadian money. These are 3 videos that you can share with them. I wouldn't do them all on the same day, but maybe they don't know anything about the $100 bill. Maybe adults don't know a lot about the $100 bill. Maybe you don't know that there's hidden numbers and words inside a $100 bill. Where would you find those hidden words and numbers? So that's what these videos will show you, how they make it, about it, and some hidden facts that are in there. So this is appropriate for any grade. So I want to make sure that they understand coins, they understand the values of the coins, they can mix and match the coins, that they understand what they're reading when they go to a store, that makes sense to them, right? That's our starting point. If they don't know anything about coins, start there. Don't rush it, just start there. Here is a link. There's a resource that we found, and I'm not a big teacher pay teacher fan. However, I am when it comes to something that's excellently done and saves me a ton of time. This is a particular resource. It's a very reasonable, I think it's only $3, but it covers every coin, as well as resources for adding piggy banks together and looking at saving money. So this is a great little one if you are looking for something and haven't got something for money. There's a sort of a fast way for you to get through it. You'll have questions that look like this. right? Where they have different amounts in the piggy banks, and we ask the student, which bank would you like? In this case, I would ask them, which bank would you like? And some of the kids said, well, is this like a trick question? They had the same amount. And yet we had a couple of kids with their hands just stretching, saying, I want B. So we said, okay, we'll bite. Why do you want B? And the reason was that if they had to go get money out of their piggy bank to spend, that this bank lets me take some money out and I still have some money left in my piggy bank. Whereas this one, I have to take the whole thing out. That's really good thinking, right? That's the kind of thing we want to hear from kids. So they know 2 5s is a 10, but in this case, I can get money and not spend all my money. If you have not got a money app, I'm going to click this one on. I'll put it in the chat box so you can grab it from there. You can save this with your kids or give this to your kids and save it to their computers as well. Okay, just a minute here. I'm frozen up. There we go. There are lots of free apps. This is one that I like because if I'm making a slide deck, if I'm making a worksheet for the kids, I use this one. So just grab it in the chat box. I'll give you a second here. Just bring it up on your screen if you don't have it already. And if you are, when it comes up, go scroll down to, you'll see the money, and then on the right-hand side, it will say open. So click on the open and then just save it to your drive. So I'm not going to go through the whole thing with you, but if you are only working on the one screen, if you can come back and just see mine for a second, I'll just show you a couple of tricks to engage right off the bat. First of all, there's a coin missing here in the bottom left-hand corner. It's still made, it's just you hardly ever see it. So to get it, we're going to go to the wheel, that little cog, click it on, and then you'll see all the coins and bills have been checked off except the 50-cent piece. So we're going to click it off because we want to leverage that. There's your half, right? Talk about halves. So I would go up to the X on the bottom right-hand corner, and that takes me back to my screen. And now I have the 50-cent piece showing. So when I'm working with this particular one, I can drag out any coin, anything I want, as much as I want, as many times as I want. So when I'm doing this with students, and I want to see if they even know, do they, put pennies all over the place, put nickels all over the place. Can they group things together in groups of 5, and then can they replace it with whatever the equal amount is, or tens, or whatever it is. Now, if I'm wanting to do more than one at a time, down here, you'll see ×1. I can change it to grabbing 2 at a time, 5 at a time, or 10 at a time. So if I wanted to show students $1,000, I could drag out 10 $100 bills to show them what 1,000 would look like. So again, I could ask them to show me an amount. So often teachers will have Chromebooks up with the kids or whatever they were using, and we'll just say, show us $254. And when we say that, we're actually asking them, I'm going to go back down to 1 here. We're actually asking them to put us in a bit of an order. So 200, and if we're going to use just base 10s, 54 means I'm only going to use 10s. I'm not going to use the 50 because base 10 system. And then 4. So you're not using the toonies, you're using the loonies to make it. So instead of giving me a sheet with columns on it, you're just asking me to do it on a blank page. And now I can say below that, show me 365, right? You're never going to run out of money this way. And then can they group them together? Can they add them? So they're pooling their hundreds together. They're pooling their tens together. They're pooling their loonies together. Can they make a trade? So all different ways that I can do my addition questions, a lot more fun for the kids than just doing paper and pencil. And I can see their thinking that's going on behind the scenes. If you want to create a worksheet or a quiz of some kind, you can go down here where this little colored wheel is. If you click it on, you can change the background color to white, which is much better if you're going to do something as a screenshot. So if I change it to white, then whatever I drag out, then I can screenshot it, put it onto my worksheet or whatever it is you want me to do. Okay, so that's just another way around that. All right, let's go back to our slide deck. So again, when I see this and I ask students, what do you see? Some will say, I see 2 rows of 5s. Some will say, I see 10 frame. Some will say, I went 2, 4, 6, 8, 10. They counted by 2s. Ask them what they see so that you know where they are and can they come up with a different way of coming up with that total. Skip count by 5s, 1 times 10. Here's my groups of 2s, so 5 times 2. You're getting at math facts at the same time. Can I trade some of this? Sure, each row is a nickel or 2 nickels can give me a dime. So really quick, they don't need to be spending a ton of time. What do I see? I see 5 rows of 5. How much do you see? I see 25. How do you know that? I can skip count by 5s if they don't know their math facts. They could say, I see 2 rows of 10 and a 5. 10 and 10 is 20 plus 5 is 5. How do they see it, right? This is where you're getting at. Math facts are what we want to work on. I see 2 10s and a 5, or I see a 25-cent, or if I went 5 by 5, then I get 25 right off the bat. Again, that's the kind of connection we want them to see right off the bat with their math facts. What do I see here? I see 100, I see 10 by 10. I could skip count by 10s, I can skip count by 5s. What is it they see and how are they counting? Where I'm going to listen as a teacher is when I hear 1, 2, 3, 4, right? If we're ever going by ones, for sure that's not working. So that's not what we want to see. Okay. So this row also sets up my unit fractions. I can see 2 groups of 5 or I see a dime. So here's my 1/20th. Here's my 1/10th. That's how is another way for me to get to the unit fraction conversation. So the goal is to end up with decimals, but that's not your goal right off the bat. Can they flip between money and putting it on a number line? And can they add it? And can they just continuously going, because what you're doing is hitting your number outcomes at the same time. You can play that game, show me this, show me that. Can you add those two together, right? What would they be? This is a slide deck. The link is in the slides when you have those. You're going to see that this is better not in slideshow format. Leave it in just the regular format of the PowerPoint as itself. And what happens is the kids can then drag these coins later on next pages. There's bills, like you can create whatever number you want. You can get them into the thousands, whatever. This is a game of show me where you can differentiate based on the ability of children. So you can say, Julia, I know that you're not able to work yet to 500. I'd like you to show me 459. Okay. And I've got Marnie. Marnie's sailing into thousands already. So I'm going to ask Marnie, her target goal will be 2,300. Okay. And I might go to Betty. Betty's working on 10,000. So I'm going to say, can you show me 9,800? And what they do is they drag out 4 different combinations of that amount of money, not counting by ones. So we ask them to be efficient. Efficient means use the least number that you can. But in this case, show me 4 different ways of showing me that number. So I can differentiate based on the ability of the kids. And you can change that number, call them group whatever you want. And you can say, so-and-so you're group 1, so-and-so you're group 2, whatever. So subitizing cards let me do all kinds of things from adding to subtracting. I can put 5 cards down and that gives me a 5-digit number or more. I can add 3 cards plus 3 cards together horizontally. That's a 3-digit number or more and add those up. So again, it's the same number of the ideas, but you're just doing it with a little bit more zest behind it for the kids. I could do it with dominoes, turn them sideways like I was saying. You could do it with a pedal, right? And if I'm weak and I'm not sure all my math facts, I could just do, can I match first? And if you've got some special needs students that just need to match number first, great. If I've got students that are ready to do some multiplication, maybe I put the dies down and I multiply and I have to find my numbers. Again, it depends on what it is you want me to do. I've put a link in here for a video that deals with the interactive. It's a fun kind of activity for multiplication facts in a game format. So again, it's just learning some of the ways that we can do some of the pieces that we want students to be able to demonstrate to us coming out of grade 3. Maybe I don't know them all. There's some resources on here, most of which you've already seen on there, but just so that you can acknowledge those. And then we want to make sure that students can get to that grade 3 outcome, which was 100,000. And it never said adding to 100,000. It said investigating 100,000. Do they know where 7,859 goes? Where does it belong, right? So can they put those values into that piece as well? Okay, counting and visualizing numbers, same thing that we just talked about. Give me a random number. What's the number that comes before and what's the number that comes after? That's also a grade 3 into 100,000. So simple, but just putting a sticky note down even for different kids at different levels. Okay, I've given you a link in here for Indigenous resources. If you're looking at that, if you're needing something, we'll always go to that when we need it, but I'm just giving it to you in case some of you are doing it in a different order. And then again, I've given you some Indigenous links in here that deal with how we might look at the quadrants. So Inside Mathematics is a resource that I think would be helpful to you in getting started if you're looking for some activities and some ideas. The Money app is the one that I just shared with you, but here's the other place to find it. That green Exploring Banknotes is another one that you can use. It's a different version of it. And Show Me the Money is that one I just showed you with the 4 sections where you can decide what level you want me to do. What's my target number? And then there's Alberta Ed Planning Guides. So if you have never seen the planning guides, these were created for your old curriculum, but they're excellent. They're outcome based. So what happens in these planning documents is you have a series of pages, usually about 25 to 30. They start off with what the outcome is. They look at what's a little bit of a pre-assessment that I could do if I'm not sure that they know something in an outcome. And then if they, they got some of it, they didn't get all of it, I need to tool them, just work with them a little bit. There's generally 6 to maybe 10 interventions that you can do, and you wouldn't do them all. You pick and choose the area that they're weak in and grab those. And then there's a bit of a post-assessment. So if you have never seen these, just click on this link and you will have access to those as well. Okay, for those of you who need my email, it is on there. And I'm going to take you to where you're going to find some of these right now so that we can see them. Now we have our tech person is on holidays at the moment, so I'm not sure if he has gone and put them up for us already. I'm going to give you 2 links. So arpdc.ab.ca. I just put it into the chat box. Okay, the other one is movingforwardcurriculum.ca. It's a second one. Now the Moving Forward one is going to close at the end of this month. Everything that's on it is still live. You can still go there, and we're still posting for a short little while. But we're going to move everything, or it actually already has been moved, to the ARPDC site. So I'll go to the Moving Forward one because it's probably the fastest one right now first. So Moving Forward curriculum looks like this. You don't have to worry about signing in anymore. You just go and go to your subject area, find math. And you'll see that here are the grades already posted. And here's a May 29th one. That was the opening one that we did. So he hasn't posted the one for today yet. That will be here. That's where you'll find the slide decks. We can go check and see whether he put it into the ARPDC one. I'll just double check. If not, it will be up in 2 days. And you will have both the slide deck and other resources that I have linked in there for you. So if you haven't come to the new ARPDC one, you're going to click that one or get into that arpdc.ab.ca. Come up here where it says new curriculum, click that on. Go to click here to jump to the new resources. And then you can select mathematics. We're going to go to grade 4. We'll pick all of the resources for now just to make it a little bit easier for us. And so here's where your curriculum comparison, for those of you who were looking for the documents, here's your curriculum comparison document. And let me just see, here's your year at a glance, the interactive one, as well as the one that's non-interactive. So what's the difference? The interactive one has all of the terminology, like I don't know what quantity is. I don't know how to explain quantity to kids. Click on quantity and it'll give you the definition. Sometimes gives you a lesson plan, sometimes gives you an activity. So it's interactive, hence the term that's on there. Let me see. And if you're looking for, I want to send something home to my parents in the fall about this is what they're learning in grade 4 math. We've created sort of a summary, a little more lay-friendly language than what you see in your curriculum document about what am I learning in grade 4. You can use it, all of it, some of it, none of it, whatever you want. It's up there for you. And I don't see the lesson on here right now, so it will be up here shortly. So this is where you can find it, either in moving forward or into the other one. Okay, I'm going to stop the recording because I know that sometimes come on.